To produce the necessary log files for my application, we first need to set up what to log. To do this, we go to the Settings and Data Logging and Upload. We now need to select what to log here. This is the current list of what I do log. All these need to be present for the application to accept the file. To add, all we need to do is go here and browse the list. To add one, just select. Now all that is to be done is to start logging. When finished, stop. This is an application I have used for data collection. It is called Talk Pro. This connects to an OBD or onboard diagnostic scanner. Through this scanner, it connects to the car's engine control unit and reports on selected data points. Also, some phone sensors are logged, such as accelerometer data. Communication is achieved here by Bluetooth. The user must select when to start logging. The data recorded will then be used by my application. This is a visual representation of some of the data points that my application utilizes. The trip file is generated in Talk and emailed by the user. This email is sent to the registered email in the application database. In the subject header, the rating can be entered. This rating can be between 1 and 5. If the application cannot parse what's been put in the subject header, it will be ignored and saved for rating later. The database diagram represents a database at the core of my application. It contains tables such as trip, recurring trips, application user, fuel, trip points, trip statistics, and a logs table. The trips table contains a unique entry for each trip, stating who made the trip, the rating of the trip, information on the fuel, where it started and ended. The trip points table contains a second-by-second view of that trip. This is where most of the data is stored. The data here is gathered from the ECU and the phone sensors. The trip statistics table contains entries generated by my application based on the information already stored in the database. This is used in the user interface and for Wecker calculations. The recurring trips table contains information on whether a trip has recurred or occurred before. The application user table contains the users of the application. This is also used in many other places to ensure data integrity. The fuel table contains information about the current fuel price based on a user. This can be manipulated through the user interface. And finally, the logs table contains information about error logging and basic logging from the user interface. This is the web interface's main login page. Without logging in, the user cannot access the system. So if I click home, we won't be able to get on. The email that should be registered in the database can be entered here, and the password for that email should be entered here. So if we log in, we can see the web interface. You can see I'm logged in as Callum at obd.aconserver.com. That's also where I send the files. As we can see here, we have a calendar indicating what days have data, which is in green, and red indicates the current selected. These are the trips that are currently on the selector, so we only have one, but that trip has recurrences on other dates. So if we select another day, for example 12, we can see I have 3 trips, none of which are recurring. Sorry, the first one isn't recurring. The second one is. If we look further down, we can see that these are the ones in the top drop down. So these are the trips on the date. So that has a trip time, how long it took, the cost, the distance, the fuel used in gallons, the miles to the gallon calculated based on the fuel used and the distance, the RPM of the engine throughout the trip, and the average speed whilst moving. The rating isn't yet calculated on this because Weka hasn't been run on this database, as we'll see later. These are the recurring trips, so we can see a recurring average for the selected trip, and the selected trip is the one currently in the drop down. We can see that given the trip in here and the trips recurring, which we can see in the list box here, that at the top it takes an average of 13 minutes to get from start to end, an average cost of 89 pence, average distance covered is 5.7 miles, the average fuel used, the average miles to the gallon, average RPM and speed. As we can see, this is a Google Maps API that I have plotted using a polyline, the trip. To get a smooth polyline, I've only used data points where the car is registered as moving, so we get as minimal jagged lines as possible. The map scales to the start and end of the trip, so if you noticed at the start it managed to show the start and end, so it will scale automatically based on the trip. If we go to the administration page, we can see as I am an admin user, we can see all of the controls. These buttons at the top, this one starts the listener for trips. These come from a place called Roundcube, which we will see later, and the restoration of all backup files in the database. This is an indicator of the file that the system is not restoring and the system is not listening. An admin can add a user, either a basic user or an administrator, given these controls. So if I type in a user that's already there, so if we put a username of Callum, as we can see that I already have Callum, and a password of anything, so if we add the account, we should get back user exists. Similar, if I try to add an account now, all the fields must be filled out, so there is validation on that. Same for change account password. If I try and change a password without entering, I get some feedback. So if I put down my current password, but make a mistake, so and put a new one, I get validation there as well. This is where we change the fuel price. So if I change that to 7.9, which predictable fuel will go up, exchange, update the price, and we can see in the log below that I have updated my price. So if I just put that back, here we can see various bits of information. We can see my fuel information that I've been recently updating, that I recently restored trips from the database, and we can see the insertion of these trips. You can also see when a trip, so the trip 2952 was identified as recurring based on the master trip of 2931. Of course, this is more of an admin thing, and it would be very useful to have direct database access to view this. In a non-administration user account, these controls would not be visible. Just to show this starting listening, so if I click start listening, I get listening for new trips, and the button has changed to stop listening. When I click start listening, it creates a new C# task, so a new thread, to ensure that that the application doesn't incur any slowdown, any lag, and this thread is then stopped using a static variable in my data access to ensure that multiple tasks aren't running at the same time. This is RoundCube. It's an email interface that allows for the viewing of emails, etc. As you can see, there are two emails here, both from myself. Any email with the email extension at obd.acornserver.com will be forwarded here. If I sent Callum an email to callum@obd.acornserver.com, it will be received here. If I send one mark@obd.acornserver.com, it will be received here as well. The application will look at these addresses and decide which user the log should be assigned to. To process these files, a task needs to be started in the web interface. So if we log on, and go to admin, we can start the listener. So we're now listening for new trips. So we should see these disappear. Yep, now they've gone, they've been processed. So if we refresh this page to get a view of the logs, so as we can see from the start, we have 2 trips. Both of them have been identified as recurring trips as well, against other master trips. So if we go into home, we should be able to see the same ones. There we go. If these are uploaded again, my application will identify that it's a recurring, a repeat, a duplicate, and won't insert it. This is done by looking at the start date to see if any of the points are identical for that user, meaning they can't be taking 2 trips at the same time on one user account. This is a weka-arf file. This file contains instances of each trip recorded in the database that has a rating. This rating, as we saw before, is given in the email system. For example, in the subject header 1 to 5. This is then given a textual description based on the value. So 1 and 2 are bad, 3 satisfactory, and 4 and 5 are good. This is what is to be classified. Here we have classified it already, so good, satisfactory, and bad. These are the attributes that we have to take into account. This is it sort of describes the trip as a whole. So we have minimum, maximum, and minimum, maximum, and standard deviation. The trip ID isn't taken into account. That's just for database purposes. This is the training file, which needs to be loaded into the model in order to classify instances that we want to try and predict based on the training. So this file, as you notice, they're all satisfactory. I've just put this as a base value, but all of these need to go through the model that I construct. So this would be a random forest. This is a Weka model containing many decision trees. This will analyze the data and for each instance give its prediction based on the training set. The training set, as the software runs over time, will become more accurate, because all of these that will be classified shortly will be added to the list of the training file. So to start this process off, all we have to do is go to the OBD Weka ratings form that contains the Weka library and start classification. This will then process all the files in the log. As you can see, all of these are given ratings. This is a developer's log, but 0 is good, 1 is satisfactory, and 2 is bad. To see this in the web interface, as we saw earlier, the line was blue and most of the trips were unrated. If we go and log in, we'll see a very different picture now. So you can see that that trip was bad. So if we have a look at all the trips on that day, so 2 were bad on that day, and we have a full list of ratings here on the recurring side. So if we switch to a different day, we can see bad. I'm seeing a theme here. So satisfactory, good, satisfactory, good. So it has done all of them.